7A, Fundamentals of Probability. We're going to begin by defining what an outcome and what an event is. If we look at two coins being tossed, I can have two coins and both of them are tails. We can write them out and we can write them as tails, two T's. And this is called an outcome, or one particular way that the two coins can fall. If we look at the second picture over here, we have a tail and we have a head. So that's tail and then head, T and an H. That's another outcome. In total, we have 4 different outcomes. They're listed over here. But perhaps we are interested in only the number of heads that shows up, right? When I toss 2 coins, I can have no heads. I can have only 1 head, and there are 2 different ways to get it, 2 different outcomes of that. And I can get both coins having their head faced up. We would describe this as 3 different events: 0 head, 1 head, and 2 heads. Now let's look at an example. Consider a family of 3 children. And let's suppose that the outcome for each child can only be a boy or a girl. Now, if we're interested in the total, all the possible outcomes, what we'll have to do is we'll have to list all the different birth orders, all the different ways to have 3 children. We can use B to represent a boy and G to represent a girl. And you will notice that we can get boy, 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 girl, boy, girl, boy, boy, girl, girl, and so on and so forth. There are 8 possible birth orders, or 8 possible outcomes. Now, we'll show you how to find out that there are 8 different possible outcomes, because it is important for us to know how many are there in total, even if we have a little bit of trouble writing them out. Now, between all of them, we can have 0 girls, right? No girls in the family, all boys. We can have 1 girl and 2 boys, 2 girls, and 3 girls. These are called 4 possible events. Now, like we said before, we have to be able to count the number of outcomes that there are. When we toss 2 coins, with 2 different sides, now each coin, the coin on the left can have a head or it can have a tail. The coin on the right also have 2 possible outcomes, head or tail. In total, we multiply the possible outcomes between the left coin, the coin on the left, and the coin on the right. We multiply them together to get to 4. And that's the 4 possible outcomes. Now, in the case with a family with 3 children, each child can be of 2 possible outcomes, a boy and a girl. Now, because we have 3 children in this case, the first child can have 2 possible outcomes, boys and girls. The second child, same idea, boys and girls, 2 different outcomes. And the third child, boys and girls. We multiply the 2's together. And because we have 3 different children, we have 2 times 2 times 2 equal to 8 possible outcomes. We can have something more complicated. Suppose we go to the restaurant. We have 2 choices. We have 2 choices for an appetizer, 5 choices for the main course, and 3 choices for the dessert. If we want to find out how many different combinations are possible, we simply multiply them together. 2 times 5 times 3. There's 3 different numbers multiplied together. Now remember, we're multiplying them, not adding them together. And in this case, we have 30 possible outcomes. Now, when we count all the possible outcomes at the end, perhaps each outcome is equally likely. What that means is the chance of tossing a head and a head when you toss 2 coins will be the same as tossing a tail and a tail. The chance of getting a boy and a boy when you have 3 children would be the same as if you have a boy and then a boy and then having a girl as your 3rd child. So suppose we say that each of these are equally likely, then when we find the probability, the probability is defined as all the different ways that our event can happen divided by the total number of possible outcomes. So what that means is, suppose we want to find the probability of having 1 girl in the family. Okay, 1 girl in the family of 3 children. Now we have 3 different ways to do that. We can have the girl last, we can have the girl second, or we can have the girl first. And then the other two children are boys. Now earlier, we found that there are 8 possible outcomes, 8 total possible outcomes. 3 of them will have 1 girl in the family of 3. So that we have 3 of them. By doing a simple fraction like this, 3 divided by 8, we say that the probability of getting 1 girl in the family is 3 by 8. And that's a very important thing that you'll have to know. That's a definition of probability that we'll use going forward. Now, when we look at a standard deck of cards, now remember, a standard deck of cards, we have 4 different suits. And each suit has 13 cards. In total, we will have 52 cards. 52 cards. Now, we want to find out what's the probability of drawing a face card. Now, you'll notice we have 3 face cards over here in the suit of hearts. We have 3 face cards in diamonds. And we have 3 face cards, Jack, Queen, and Kings in spades. And we have 3 more in clubs. Altogether, we have 12 face cards in total. So we will say that the probability to get a face card is 12 divided by 52. Now, most of the time we will simplify. We'll simplify 12 by 52. We'll divide the top and the bottom by 4 to get to 3 over 13. Now, sometimes when you're not sure if you have the correct simplification, just remember, if you take 12 over 52 and you put this into your calculator, you should have the same number. You should have the same number as 3 divided by 13 when you put it in your calculator. Another way to find out what the probability is by making observations. Sometimes we're not sure how many different possible outcomes are there. All we can do is we can just look and we can just add up all the different times that one event happened. This is called the relative frequency method. So for example, if we see that it rains 100 days in a year of 365 days, we can say that the probability of raining is 100 over 365, right? Assuming that the weather is random, of course. So this is what we would say in our definition. It's just how many times we see divided by the total number of observations. Now, suppose we toss a coin, and these are the results. We toss 2 coins, and these are the results. When we find the probability using the relative frequency method, all we do is we take the times where no heads shows up, there are 22 times, and we just divide it by the total of number of times where we did our observation. So in this case, it will be 22 over 100. And in this case, we can leave it like that, or sometimes I can put it into my calculator. I can do the calculation and write it in decimal form, 0.22. And of course, for some people, we would then take this one more step further and say that that's 22%, right? That makes it easier to have to understand. That says that if I toss 2 coins, 22% of the times I will have no heads showing up. Now the other 2 situations are calculated accordingly, same way. Okay, we just use different numbers. Sometimes we want to find the probability of something not happening. In this case, we want to find the probability that it's not a 4. Now, we could do this the long way. We can say 1 is not a 4, 2 is not a 4, 3 is okay, right? 5 and 6. So we have 5 different choices out of 6. 5 out of the 6 is 5 out of the 6 different outcomes when I roll a die is not 4. And like I said, the probability that a 4 doesn't show up is 5 over 6. Here, we're going to teach you a different way. And a lot of times, this other way will be easier to do. What we'll do instead is we'll think about the probability of getting a 4. The probability of getting a 4 is 1 over 6, right? There's only one number out of the 6. There's only one outcome out of the 6, that's a 4. The other ones are not 4. So what we'll do is we'll subtract the other ones. The probability of 4, right? It's 1 over 6. The other part is not 4. And what's the other part? The other part is 1 minus the 1 over 6 that we have. It's a little bit like 100% minus the 17% or so that we can get a 4 with. So this is what we'll do when we do the subtraction. And this will come in handy in a lot of the situations. Now, let's think about the family with 3 children again. In this case, we want the probability where we do not have 2 boys and 1 girl. And this is a little bit hard because if we want to do it the long way, we have to think about what's the probability of finding 0 girls? Right, 0 girls. And what's the probability of finding 2 girls? And what's the probability of finding 3 girls? And we have to add them all up. And that's a lot of work. But what we can do is we can do the probability of 1 girl. And we know we have 3 of them, right? 3 out of 8. 3 out of the 8 outcome has 1 boy, have 1 girl and 2 boys in it. The girls, that's the first child. girl as the second child or girl as the third child. Now, what we'll do in order to find the probability that we don't have 2 boys and 1 girl, we'll take 1 subtracted by that. We'll take 1 subtracted that. And you'll notice over here, when I take 1 subtracted by that, we're taking 1 subtracted by 3/8. Okay. Here I use the decimal form, but you can also think about 1 subtracted by 3/8. And if we do this with fractions, if we do this with algebra, what we'll have to do is we have to convert this to common denominator, right? We will say that 1 is 8/8, and then we want to subtract 3/8. And this is easier to understand. We have 8 different outcomes. 8 is the total number of outcomes. 3 of them give us 1 girl in the family. So 5 of them, right, 8 minus 3 must be not 2 boys and 1 girl, right? Must be what we want, not 2 boys and 1 girl. So 5/8. And so that's the answer, 5/8. Or if we use decimal form, 0.625. Now, a couple more things. One is called the probability distribution. Now, this is not anything new. What we're going to do is we're going to write down all the different events. In the case of 2 coins, we can have no heads, 1 head, and 2 heads. And if we write the probability to all of them, right? If we write the probability to all of them, we have 1/4. And why 1/4? Because we have 4 different outcomes. One of them is 2 heads, so 1/4. 1 head and 1 tail, it's actually 1/2. The reason is because we have 2 different outcomes that have 1 head in it and 4 outcomes in total. So 2 divided by 4, that's the same thing as 1/2. When I write everything out into a table, this is called a probability distribution. Right? Nothing new. We just have to do this multiple times. Now we might have to make a probability distribution when we roll 2 dice, and we want to find the sum of the dice. Now it's a little bit tricky if you don't write anything down. So when we roll 2 dice, it's a little bit easier to write down all the different possible outcomes. We can have 1 and 1, right? 2 and 1, 3 and 1, and that's just all the different numbers that we can have on our die. And you'll notice we always do this systematically. I keep the die on the right-hand side to be 1, and I just change the number I get on the other die, on the die on the left. And then I try to change it into 2 for the second die on the right. And then I change it into 3, change it into 4, and I just repeat. Now you'll notice if I want to find the probability where the sum, if I want to find the sum to be 8 of 8, if I want to find the probability of 2 dice having a sum of 8, what we'll have to do is we'll have to count the number of outcomes 6 times 6, right? 6 different numbers on each die. So we have 36. In the denominator, that's the total possible outcomes. And you'll notice over here, we have 5 different outcomes that's highlighted to have a sum of 8. So in this case, the probability to get a sum of 8 is 5/36. Now, when I do a probability distribution, we have to do the probability for every single sum. So we have to find the probability for a sum of 2, a sum of 3, all the way up to 12. So we have to do them all. And you can look at the chart to do it. What you'll notice is if you add up all the probability, it adds up to 1. It adds up to 100%, right? If I want to do this in percentage form. One of the last thing to tell you is the idea of odds. When we do the odds, we are not talking about probability. We are thinking, we're thinking about the number of times that our event happened and the number of times the event doesn't happen. So for example, if I look at odds against rolling a 4 on one die, what you'll notice is that to get a 4, there's 1 out of 6, right? 1 out of the 6 numbers on the die is a 4. The other 5 numbers are not 4. So that's why it's 5 over 6. 5 different numbers, that's not 4, out of 6 in total. And when we do this division, you'll notice when I divide, I multiply by the reciprocal, so I flip the denominator, 6 over 1, and you'll notice I just get 5. You'll notice I just get 5 over 1. And if you think about it, that means on a die, it has 6 sides. One side is a 4, right? One side is a 4. And the other 5 side is not 4. So that's how we do odds. We're not doing the probability. We're just doing all the different outcomes that's either a 4 or not a 4, and we divide them. In this case, the answer is 5. Now, a lot of times when we talk about odds, we say 5 to 1. 5 to 1. We say it as a ratio, right? We look at this, we look at 5 over 1, and we read it as a ratio, 5 to 1. Now, in gambling, the odds that we use are usually odds against. Odds for is just the same thing, but flip in the reciprocal form. Now, let's think about the odds of getting 2 heads when I toss 2 coins. When I toss 2 coins, to get 2 heads, it's 1 out of the 4 possible outcomes. The other 3 outcomes are not getting 2 heads, so 3 over 4. When I do the odds for, I take the probability of 2 heads divided by the probability of not 2 heads. This gives me 1 over 3, right? We really don't look at the denominator for. So we would say that the odds for getting 2 heads is 1 to 3. The reciprocal, if I do it in the reciprocal form, the odds against getting 2 heads is 3 to 1.